If, after replacing one or more blown fuses, the system continues to blow them again, then it could be a short between the protection here and that of the next circuit. Troubleshooting a control circuit may not be as complicated and difficult as it might appear at first glance, as long as we keep our technique according to a step-by-step procedure. First of all, we need to have an updated and correct version of ladder diagrams, wiring diagrams, and of the layout of components in the enclosure, including the terminal locations which are connected to devices. If we don't start by having this, our task will be much more difficult, perhaps by a factor of 100 or more. It is better to identify the area in which a problem may have occurred or where the symptoms seem to be. This, in turn, could give us further direction into finding the problem. In a control circuit, there are two main areas to investigate, namely the power section of the circuit and the logic section, or the ladder circuit part. The power section of the control circuit must be checked to ensure that incoming power is available to the circuit and that the transformer is operating correctly. To perform this check, we first disconnect power to the ladder circuit so that, if a short was the problem, it cannot occur during this check. First, we would check the incoming power to the primary of the transformer by testing the L1 and L2 voltage across the H1 and H4 terminals of the transformer. If the voltage is correct, in this case 480 volts, then we would check the secondary for the proper voltage across the X1 and X2 terminals of the transformer. If the voltages are correct, in this case 120 volts AC, the transformer is working okay. If not, the transformer is faulty and requires replacement. Next, we would check the fuse protection to the control circuit. So we close the disconnect and measure the voltage from the load side of the fuse to the X2 side of the transformer. We should read close to 120 volts AC. If no voltage is read, then the fuse is bad. To make sure that voltage is present after the disconnect, we could also put the voltmeter lead in the supply side of the fuse to ensure that the disconnect is indeed okay. If the fuse is blown, we would need to replace it. However, this condition could indicate that a possible short or ground fault could have occurred in the control circuit, thus blowing the fuse, or that the kVA power of the transformer was too small for the number of loads in the circuit. As we know, a transformer is rated for a specific kVA, which is the voltage times the current it can supply. The loads of the control circuit may be composed of a number of relays, counters, timers, starter coils, solenoids, and others, which could overload the transformer and reduce the voltage and increase its current to a point which could even blow the fuse. Although overloading the transformer seldom occurs when a control system is first designed, we need to keep track of the devices we add to the circuit. For example, during an expansion of a system. If our 120 volts transformer is rated at 2.4 kVA, it is capable of delivering 20 amps without exceeding its capacity. If the sum of all the devices on at the same time exceeds 20 amps, we will see faults in the system.